In the last example, we showed how we could start with 2 points and find the equation of the exponential function that goes through those 2 points fairly quickly and fairly easily. Once you get the knack of this is actually very quick to write down. The Wiley plus problem that we saw in the exponential function said basically they would give us something like this without a reason. They were assuming that you had seen how to do that in an algebra class, and then said, what are the effective rates of growth and what are the continuous rates of growth? And so now that we actually know why we're actually having to do that, let's just practice starting with something like this and finding the continuous rate of growth and the effective rate of growth. Remember that both actually have to start where we rewrite this as a constant times a constant to the x. And to do that, I'm going to have to use my rules of exponents a little bit and then group. So I have to have my 4.7. I'm going to rewrite this as, let's see here, I want 1.2 to the 4.7 to the x over 4.9 times that same base, 1.2 over 4.7 to the minus 2.5 over 4.9. I'm going to collect my constants. So there's 4.7, and this last thing over here doesn't have any x's in at all. You might not like the look of it, but there's no x's in it. That makes it a constant. And I get minus 2.5 over 4.9. There's A. Now, B, I need to take what's left with the 1.2 over 4.7 and rewrite that as something to the x. This is something we did practice. I'm going to rewrite this as 1.2 to the 4.7 all to the 1 over 4.9 all to the x like that. Now that's B. Now let's go find the effective rates of growth and then the continuous rate of growth. The effective rate remember, to find the effective rate, what we had to do is find B, remember that B was equal to 1 plus R, and then solve for R. So R here is going to be B minus 1. Now I believe that Wiley was only asking for so many decimal places, so what I'm going to do is put our B into my calculator, and I get a B of 0.756. I guess I'm going to carry 4 decimal places like that. Minus 1, and then I subtract 1, and I get something like negative 0.2432 when rounding to 4 decimal places. And remembering that this is a rate, I'm going to get negative 24.32 rounded percent. That is decaying at a horrible rate, unless I'm, yeah. Anyways, that's the effective rate of growth. It's actually a decay rate, and it's actually a pretty big decay rate, which makes me kind of depressed. Anyways, that's how you find the effective rate. You have to rewrite this so it's a constant times b to the x, and then remembering that b is 1 plus r, solve for r. Now, how do we find the continuous rate? Continuous rate. Well, remember what we're trying to do here is rewrite all this as a times e to the kx. In fact, why don't we rewrite that as e to the k times x like that. And the reason I did that is we want to solve for k. So what I'm going to do is take my b, which is being raised to the x, and set it equal to e to the k, because that's also being raised to the x. So I'm going to take my 1.2 over 4.7 to the 1 over 4.9. I know that's e to the k. We take the ln of both sides, and if I want to, I can bring down the 1 over 4.9. It really doesn't matter. I'm going to have 1 over 4.9 times the ln of 1.2 over 4.7. That's going to be equal to k. And according to the calculator, I think we're going to get negative 2786 rounded. So that's 27.86%. and that's how you would find a continuous rate. From the nice easy equation that we got, we had to do some rewriting to find the continuous rate and finding the effective rate. But all three are very, very important. Finding the equation, finding the continuous rate, finding the effective rate. And biology in particular likes people to be able to walk in on being able to just write down the equation of an exponential function from 2 points. Especially when you write it like that, you can actually piece together the original data from that. That's an awesome thing. Anyways, that's the end of that example.